Hi, this is Margo. This is Sunday evening, May the 30th, 2021. We made it through another week. I hope everyone is safe and doing as well as possible. I'm hanging in there, and I'd like to welcome everyone to the show today. This will be my weekly roundup for methane, climate, sea ice, and a few earthquakes and maybe some other stuff, I'm not sure, but this will go on my YouTube channel. And if you'd like to have updates during the week, I'd recommend you come over and join us on my Subscribe page, and you can see what's going on during the week too. We'd love to have you there. So before we start on the methane, I wanted to show, this is NASA Worldview for today. This is the Antarctic. I've got the nighttime layer turned on, and this is an extraordinary view of the iceberg that broke off. This is that A76 here in the Antarctic. This is the Weddell Sea. Over here on the left side is the Larsen. These are the Larsen ice shelves over here. And this is the Ronnie ice shelf here, Weddell Sea here. This is the piece that broke off, I don't know, about a week and a half ago. Huge. And see, it's already coming apart. These pieces have come apart. The sea ice around here is quite thin, so it's not really holding it in. But that's just a phenomenal view, just outstanding. And I wanted to show you that. So let's go back and see what it did this week. Now here we are. Well, last Sunday, on my show last Sunday, that's what it looked like. Just totally cloudy. Now here we are on the 25th, and see, it's still intact, one big piece, but it's broken away from that ice shelf still. Look and see that east end breaks up into a couple of pieces. Here's a chunk. Let's see, where did that come? That's moving around. It looks like that came off too. So here's the 26th. Now watch. See, these are moving out fast on the 27th, 28th. Look how it jumps out there on the 28th. Here's the 29th, and here we are today. So it looks like it's getting ready to move out, but this ice will hold it in. It's not going anywhere with all of this ice in the way. So there's that. We also have, you'll see, we've got methane coming up around the coastlines of the the Antarctic. Down here on this western peninsula, we've got methane coming up. I'll show you on CAMS. Also, by this Brunt ice shelf, see, here's the piece that broke off back in, when was it, April. That's still there. So we got methane coming up there. We've got methane coming up at the Avery ice sheet here on this east side, and maybe a couple of other places. We'll check it out. So that's what we've got going on there. So let's get on with methane. And the reason, what am I doing? The reason I'm tracking methane is because we know that there are huge methane stores all over the planet, but especially in the Arctic, in the sediments in the seafloor, in the Arctic Ocean, but in the permafrost as well, in the lot in Russia, Canada, different places, and that's that can go, just any of that can just go at any time, and especially with the warming and the melting of the ice and everything. We're at levels where we haven't seen before, and since we've been tracking, since they've been tracking methane levels. So it's it's pretty scary, and so I'm combined that with the sea ice, and those are kind of the two areas that I like to track and follow, and earthquakes and some other climate related things, but mainly methane and sea ice. So here we're looking at the NOAA data for yesterday, the 29th. This is the 477/469 millibar reading. This is the Met-1 satellite in the morning. The mean or average was 1903 parts per billion. The high reading was 2371. And so we've got pinks coming, see, down around this coastline on the Antarctic. Now you'll see on CAMS, we'll see methane coming up down there. This pink area, that's the range, that's the high range between 2,000 parts per billion and whatever this highest number is here. And it's different on each picture that we see. And it can, so see where you see this pink, that's somewhere in that range. So you know that where it's pink, it's 2,000 or higher, up to whatever the highest number is there. In the afternoon, the mean was 1903, the high reading was 2343. On the Met-2 satellite in the morning, the mean was 1884, the high reading was 2569. And in the afternoon, the mean was 1884 and the high reading was 2425. Here's my spreadsheet and chart where I'm tracking all of this. Started tracking this March of 2019. We were way down here under 1860 parts per billion. And here's where it went up. Got the highest in 2019 in October, and then it went down, the seasonal decrease. Then it started going back up in February of 2020. Then we had a little reprieve where it went back down, then started going back up in June, July, and then it peaked out in September and October, the same level of 2020, way up here above 1900 parts per billion, and then went on the seasonal decline. It hit the lowest in January here, so it was later, it was about a month later with finding the lowest number, and then we've been on this upward trend since then. And so and since May, so it's been upwardly trending since February. See, pretty steep there, and then in May it's been going down, and Now it looks like it could be back on the upswing. So for the 29th, it averages out to 1893.50 parts per billion. That's showing an increase over last week of 0.75. Now, for the 3 weeks before that, we saw overall decreases, and we saw a large decrease in my last show of 3.75, but now I think it's back on the upswing. And we're 18.75 parts per billion higher than this time a year ago, and we're 36.25 parts per billion higher than March the 1st of 2019 when I started tracking all of this. Here is where I'm tracking it on a daily basis, and this is what I report on during the week on my Subscribestar channel, along with other things. And so let's see what it did this week. And the Subscribestar channel is a good way to support me because I don't make any money doing this. My YouTube channel is not monetized, and I'm not paid by an organization to do this or anything, and I'm just a citizen researcher, just doing this to see what's going on. So if you'd like to support the effort, that's a good way, or I've got a PayPal link also in the description box below, and it's very much appreciated. So here we were in my show last week. On the 22nd, we were at 1892.75. So again, it had gone down that day. And then on Sunday it went up 0.5. Monday it went up 0.25. Tuesday a sharp decrease of 2 parts per billion. Wednesday it went up 1.25. Thursday it went up 0.5. Friday it went up 1.25. And then Saturday it went down 1.0. And so the overall decrease for the week increase was a 0.75, and here's our yearly change from where it's up here in the top of the spreadsheet, from May of last year. There's that. Now we'll go on over and look at the CAMS data. This is the Copernicus Atmosphere Monitoring Services page. They're out of the EU. We're looking at methane forecasts. I have Saturday the 29th pulled up, Arctic view, and surface level ready to go. So the data is for Saturday, and the forecast period is Sunday through Wednesday. So this is still billowing here by Comsomolets, and no one's talking about that except for me. And why no one is going out there to investigate why this has been billowing here for the last year and a half is beyond me, except that it could be in protected territory by Russia. I don't know, but it seems to me like, since that's the highest readings in the Arctic coming up that somebody would want to go test that, or, see what the source of that would be. I would think that would be like the main study area if I were going to be out there studying, but so far that's not been in any of the study areas of anyone that I've seen. But that reading, that dark, that's a range, it's a huge range between 2160 and 10,000 parts per billion. So, that could be blowing up all the time, and we don't know. And how much methane has that released overall when it's billowing like that day in, day out? I mean, for a year and a half at least. Since January of last year, when they changed something, some algorithm or something, because it had been coming up down here more closer to this north end of Novaya Zemlya in the Kara Sea. And you can see that in my videos where you go back, and they're all archived on my website and also on my Vimeo channel. So I just don't understand, and I'm real frustrated with this whole scientific community that, where's the data? If you want to see, I mean, I would think that would be the big test area, and let's see if there's a nuclear submarine that's sunk and it's, melting through and, blowing something up in the seafloor, or if it's a crater that's opened up, or, what? Let's see what's causing that. I mean, it's not cows farting. I don't think they've got any dairy farms up there on Komsomolets. Thank you, Larry, for that suggestion. That was cute. I liked that. Made me laugh. So I don't think we can blame that on cow farts or cars. So we also see it streaming up here. See, off of the UK and out of the North Sea. These are all signs of higher methane readings. We're getting higher background colors here in Russia. See, it's going up to lighter greens and yellows now. That's a sign of methane increasing. It's also coming back to life here in southern Alaska. This is an area where it's got high methane, especially in the summertime, and this is an area that gets a lot of earthquakes. It's volcanic in nature too, along there. That's the part of the Aleutian Island chain. And Alaska has a lot of permafrost as well. We've got our problem spot popping up here in the North Atlantic off the coast of Canada. And, that's another place that could be studied. I mean, I've got all kinds of places for an expedition to go. But no one's asked me yet. But when you look at this on a daily basis, you get an eye for what's going on. Now we'll look at the North Pole view. Now you can see the UK. See, it's filled up. It's really coming back to life. UK, Ireland, Germany, this whole European area. Look, See this wave moving out from France, that green and yellow. And see the Scandinavian countries, they're coming back to life. See Norway, Sweden, Finland, and now here's the Persian Gulf down here. Here's India. Here's China. Look, Korea's filled up. Here's Japan, that's filled up. And see these waves. See the lighter background colors in the waves moving out. And then here in North America, look at the US. That's awful. That's just like a big black blob from see, just south of the Great Lakes. See, and it just fills up. That's awful. All the way down to Texas, down to the Gulf of Mexico, actually. Look at that. See, it just spreads out, and then to the East Coast. And then we got Southern California. It's always, that's a big emitter. And then see Northern California, like the San Francisco area. Now we'll look at the global view. See these light blue, that's methane coming up. This is around the Antarctic. There's a whole bunch of places. See here, this is the Western Peninsula. We should look at the Antarctic view. We'll look at that in a minute here. Anyway, the purple's gone. Remember the light purple that we were seeing? That's gone. That's been overtaken by the dark blue, which is a higher reading. That's up to 1800 parts per billion, the light blue. We're seeing, it's a dark blue, sorry. Then we're seeing the light blue starting to drift further south, and it'll start overtaking the dark blue, and that lighter blue is right here on the chart, 1820 parts per billion. That's this color here. You see it streaming off of South America. Let's hop down to the Antarctic and check out the methane here. Okay. Here we go. So just to orient you, let's first of all, let's look at total column, just so you can see where the outline of the continent. Here's the Western Peninsula. Here's South America. This is the Ross Sea down here. Right here's the Weddell Sea. Right here, right in here, is where that iceberg broke off. Over here on this east side, that's the Amory ice sheet. Here down here is the Ross ice shelf and the Ross Sea. And so we're seeing like these greens are coming down further and further, and just very little blue and purple here. So let's go back to surface so you have an idea where the coastlines are. And so we've got light blue here. This is kind of by Pine Island Glacier, that area that comes down. Look at all of this on this Western Peninsula. I've never seen it like this. Watch. See the blues come up? Look, it's all the way up. Look at this. And then here, this is where the Brunt ice sheet is, or ice shelf. Then it comes, see this whole edge here, and here's a little bit popping up on the north side. Here's the Amory ice shelf. Look at that. See the blue there? It's incredible. So it looks like I'm going to have to be tracking this too in the Antarctic. And it's dark down there. You saw I had to have the nighttime layer on to see anything. It's totally dark, and now all this methane's coming up. You know, that makes no sense. Unless it's because, you know, it heated up after their summer season, and even though it's dark, it's still coming up. So anyway, there's that. That's disturbing. Now we'll look at 500 HPA. So look at the greens. See how they're coming all the way to the bottom of the picture here. And as it heats up, the reds kind of spread out. The reds like to gather in the colder areas, but now they're spreading out more. It's highest down here in India right now. And then total column, that's the methane added up through all the layers. And today we can see it's highest over northern India, all the way across that northern edge there. Then China is next to that. There's that. Now we'll move on to sea ice. Now you're going to see some changes here. I know it's been hard to notice any changes in our slideshow, but you're going to start noticing some pretty good changes with the melting here. So here we are today from Climate Reanalyzer. This is sea ice and snow cover. See the dark blue, and then the shade of blue where it's starting to melt, but it's started. So there it is today. Here we were last week when I did the show on the 23rd. So we'll just click through and you can see the changes, mainly around the edges, but also around these islands. And here in the Lattev Sea, that's opening up quite a bit too. So here we go. So here we were last Sunday. That was a big change, huh? To Monday. Here's Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. So we're seeing it thin out really fast, and you can see the blue come across this whole Chukchi Sea area too. So that's on the melt. Now, this is from the Navy, U.S. Navy website. This is their model of sea ice thickness for the Arctic. Here we are today. The color ledger on the right hand side shows us the thickness. This dark purple is about 1 meter thick. So, and then the light aqua is about 2 meters thick. And then the green is about 3 meters thick. And then the orange, red orange, is about 4 meters thick. Not much of that. The dark reddish brown is about 5 meters thick. Not much of that either. We're seeing, so let's zoom in here. So these white areas, that's where it's opening up and melting. The light purple, this lavender, that's just a little fringe of ice, and lots of open water between the pieces. So I've named these quadrants 1, 2, 3, and 4 just for reference. So quadrant 2 is going pretty fast, and we can see that here in quadrant 2 it's really thinning out. It's going down into the purple here. Here in quadrant 1, next to the access line, see there's a hole opening up just above the North Pole here, and then up here around Novaya Zemlya it's melting pretty good, and around the coastline here's the Yamal Peninsula. See, that's all melted out. This is Severnaya Zemlya. Here's Komsomolets, where we've got the methane billowing, and to the left of that, that's all opened up. This is in the Laptev Sea, and the coastline is starting to melt pretty good. And this is the New Siberian Islands here, and we can see a whole area that's opened up along from the coastline up along here. And then we can see the purple that's come in along this coastline. Now this area is where the East Siberian Arctic shelf is located. It's in sediment, you know. That's where where Natalia Shakova and her crew found lots of huge methane stores, but Igor found many more recently, and they're all throughout, and it's methane that's frozen in the sediments in the seafloor that's becoming destabilized, and it's melting. It's starting to melt because the water is so warm, and it's coming up. So that's why I'm showing all of this. And the sooner the ice melts, the more, or that didn't sound good, but anyway, the more the ice melts, the more open water we have, the more it heats up the sediments on the seafloor, and then everything, methane starts melting, and hydrates start melting, and then starts coming up. And in addition to that, we've got all the permafrost around on the ground. We also had permafrost frozen in the sediments as well. So it's a very complicated area, complicated subject to try to explain easily, but just know that we're in big trouble. Up here in the Okhotsk Sea, this is Russia here, there's just a little fringe of ice left over here, and just a little skim along the coastline here. So that's melted out. Here in the Bering Strait, see, that's quite thin. That's pretty much opened up, and it's coming away from this Alaska and Canada coastline. This is opening up here. This is the Beaufort Sea. This is where the thickest sea ice migrated down. It got moved down because of the ice drift during the winter, and it's got consolidated down here right around this area, and that's where you see the greens and just a few little reds, not many, but most of it's here in the Beaufort Sea, and that's starting to open up too. Then so we're seeing a lot of thinning as well here in the Baffin Bay. See, it's opened up here. This is as part of the nearest strait. The ice bridges that go across from Greenland over to Ellesmere Island, and that's when that goes, those will melt, and then the ice, that's a big exit point for the ice, as well as these tributaries is a big exit point. Another big exit point is the Fram Strait over here on the east side of Greenland. So we can see the colors changing from aqua down to the light purple, and down to white where it's nothing. It's totally melted out. Here's the Hudson Bay. That's melting. See, around the edges a lot, and it's thinning out in the middle. So that's what we've got today. Here's the 30-day animation. Now the data goes back for 3 weeks, and then their model goes out, forecasts out a week from now. So the forecast goes out to June the 6th. Now look, this Hudson Bay is really, it's going away fast. Let's see, it's been raining here. There's been a huge system that's kind of stalled here in the North Atlantic, and it's been raining on this southern edge of Greenland, and also this warm air that moved up over to the western side, and you're going to see it, the ice has already started melting all around the edges of Greenland. It really spiked up this week with the melt. And we can see in the forecast, see this ice on the east side of Greenland, that's going away really fast. Let's zoom in. So we can watch the colors change from the aqua down through the blue down into the purple. See here in quadrant 1, that's just going to melt out so fast. This is Svalbard. Here's Franz Josef Land. See, that's opened up here on this right hand side. look at all this opening up here in the Laptev Sea. See, that's, and last year, remember, all of this melted. All of this around the Russia coastline, it melted pretty early. So, I mean, every single bit of this melted last year. So this is all just first year ice. So it'll go fast. Here's the Beaufort Sea view. This is sea ice thickness again. So Alaska is down here. Here's Canada all along here on the right side. So we just have a little skim of thickest ice, just a tiny bit that's up into the 5 meter thickness here. And then we've got greens, which is about 2.75 to 3 meters thick here. And like I said, this is where the thickest ice ended up consolidating. Here's the 30-day animation. Again, the data goes back 3 weeks, then the forecast period goes out a week from now to the 6th. So with this Beaufort gyre, it tends to go in a clockwise direction, and then it switches and goes in a counterclockwise direction, and so this ice gets tossed around, and so it'll get broken up pretty fast. In fact, there's a hole opening up right here. You can see in between the greens. Watch right here. Watch here. There is a hole opening up there. We'll see it on NASA Worldview. Here's the Baffin Bay today. You can see how much it's melted down here on the Canada coastline. This is Greenland over here. And in these tributaries, see how much it's melted. And this color ledger, this darkest, is only 2 meters thick, so this is a whole different scale than what we just saw. Here's the 30-day animation. Now this model, Baffin Bay, they just set this up in February of this year. We didn't have this before this year. So there's that. This is sea surface temperature in the Baffin Bay. This is the 30-day animation. And it goes up to 4 degrees C. That's the highest number on their chart here. I'm wondering if it's higher than that. I don't know. But you can see how it's really heating up. And so as the ice exits and comes down, it's melting really fast as it meets with this warmer water. Now we'll go down to the Antarctic. This is sea ice thickness for today. Now we're seeing growth. See, it's coming out here around this from the peninsula out around the Weddell Sea and on this northern side. Look at, I don't know why it's open here at the Ross ice shelf. I don't know why that is. And see the white there? That's where the iceberg is that I just showed you. But it doesn't freeze right up to the coastline on some of these areas. So we're seeing a lot of methane come up here on this western peninsula. Also down here in this, I don't know the name of this part, but Pine Island Glacier is here, so it's this part that just juts out. We can see that the ice is quite thin there along that coastline. We're also seeing methane here at the Amory ice sheet, where that indention is, and all along this side here from the Brunt ice shelf up, and a little bit on this northern side. Here's the 30-day animation. So again, the data goes back 3 weeks. The forecast goes out a week from now. And so the extent is coming back pretty good. See it's growing back there. It had gone in, it had retreated, and then it's coming back out there. And it's thickening, you can see. And this sea ice, it has to grow back every year. And so it doesn't get real thick. There's that. That's all of those. Now, let's move on to National Snow and Ice Data Center. This is the Sea Ice Index. This is I've chosen the Arctic Daily View, the blue marble, and concentration. If you just want to see the extent, you can click that. But I like to see concentration, and where you see the darker blues, that's where, in this case, where it's melting, where it's coming apart, where it's not as concentrated. When we look at NASA Worldview in these areas, you'll see open water between the big pieces of sea ice, and it can be very thin, just a skim of ice too. So that's a big change from what we saw last week, isn't it? Here's their chart for sea ice extent, and the blue line is this year, and we can see it's still going down. This is as of yesterday. The dotted line is 2012. We're still below 2012, which had been the lowest that we've been looking at. And then this gray line is the median average between 1981 to 2010. But we're well below that. So going into this summer, and we're below where we were in 2012 as far as extent, and it was a lot thicker in 2012 than this year. It's not looking good. And from what I've heard being reported, a lot of the people, the climate scientists and the peer-reviewed literature and stuff, they're predicting the first ice-free Arctic to be in the summer of 2022. Could it happen this year? Absolutely. And remember, we don't have to have it totally it's what within million square kilometers for it to be considered ice-free, which is just a little fringe of ice. So, doesn't have to get that low in order for us to start seeing some really devastating effects on all the different climate systems, which is what we're already seeing. Now we'll look at the Antarctic. Here we are today. This brown line is the median line for extent. So it's coming back out. Now look, it's past that up here on the north side. And then the blue is the concentration. Here is the graph. Now here we are with the blue. Now this is this year. This dark gray is last year. Last year we were at the lowest. And this year it started refreezing early in the season, and so we got a jump start. Now this light gray, this gray line is the median. And so it's going down, averaging out with, it's almost at the median now. So it's not keeping up with the jump start that we had, meaning the refreeze is slowing down. There's that. Now we'll look at the Greenland ice sheet. Here we are. It's still on National Snow and Ice Data Center. They track this from April through October of every year. Now this is not good news. This is as of yesterday. They show where it's melting. The salmon color is where it's melting, and you can see, look, on almost all the way around. That's incredible. It's so early in the year, in the season. Look, all on this east side and all the way down, and then on the west side, look at this, and way up here by that's where it's opened up on the sea ice, and look up here on the northern part as well. So that's incredible. That's huge melt. Now this one shows the cumulative melt days for this year since January, and the colors go up in the rainbow or backwards in the rainbow from blue up. And so wherever you see blue, that means it's already been melting this year, and we're seeing it all around the edges. That's incredible. So like this color of blue is 10 melt days, dark blue will be 20 melt days, and so on. Now here is their graph for the melt extent. This is as of yesterday. The red line is this year. This is melt percentage. The dotted line is the median. And here we are, May. Look at this, it's jumped up. This is as of the 29th. Look at this. It peaked up right here at about, that looks like about 8%. It's way up above the average. That's not good. So when you have the Greenland ice sheet already melting like that, that's cold water coming in, and this is fresh water that's coming into the ocean. It also changes the weight of the continent there, and the weight on the tectonic plates, and so it will also cause more shifting of the plates, and so we'll see more earthquakes. And we've been seeing quite a few earthquakes, Arctic earthquakes near Greenland, especially in the last, I don't know, couple of weeks. So there's that. Now we'll tour through Climate Reanalyzer. This is maximum temperature for today. We can see the greens. That's above freezing. That's all air temperature that's above freezing over the Arctic Ocean there. And I'm going to focus on the Arctic just for our show right now. Here we have 2 meter, well, for mostly, and we'll look a little bit at the Antarctic. But this is 2 meter temperature anomaly. See the browns over all of the Arctic region here, browns over Greenland, reds and browns here in northern Siberia. And see, we've got reds along with purples, so this is colder than normal, this is warmer than normal, and right next to each other in the Antarctic. Worldwide, we're up 0.3 C higher than normal. The northern hemisphere is up 0.7 C. The Arctic is up 2.3 C. The Antarctic is 2.5 C lower than normal. The southern hemisphere is at minus 0.2 C. The tropics are up 0.5 C higher than normal. But everybody's got their eye on the Arctic because it's warming. They're saying now 2 to 3 times faster than the rest of the planet. And so it's this 66 degree north latitude, and above that what is the big focus. Now here's precipitation, and the green is rain. You see all of this rain even on Iceland and here all along Greenland. This has been going on pretty much all week. That's insane. So that's one, and see there's snow coming inland. That's one reason that we've got such a melting of the ice sheet. And see the rain here in Russia, and wherever it's raining in the Arctic, there's going to be permafrost that will be thawing. So there's that. Here's the jet clumps for today. It's not a jet stream, it's just pieces, and we can see this craziness. That's why the cold air is just swooping down. It's not holding it in, and so it's causing all these hot areas right next to cold areas and weather chaos. Severe weather where you have those two meeting. Look at this southern hemisphere. We saw sea ice and snow cover. Here is sea surface temperature anomaly. This is as of yesterday. Now we do have some blues up here in the Barents Sea and the North Atlantic, and so this is colder than normal, but it's still not going to keep the melting from happening. And then we're seeing the browns. That's warmer than normal. Here in these Great Lakes, we've got browns and reds. And here off the coast of the U.S., see, we've got the reds and the pink. So that's up to, the red is about 5C, higher than normal, and the whitish pink is about 6C, higher than normal. The dark brown is about 3C. This medium brown is about 2C, higher than normal. So here in the Pacific is going to be a problem area where that's higher than normal. Also down here off the coast of South America in the South Atlantic. Also in the West Pacific around Japan. And once things start heating up, we'll see all of these inland lakes and seas, they'll all start heating up. See, the Caspian Sea, it's already up into the red zone in this northern part. Worldwide, we're up 0.3C, higher than normal. Northern Hemisphere and North Atlantic are up 0.4C. The North Pacific is up 0.5C. The Southern Hemisphere is up 0.3C, and the Equatorial Pacific is in balance between blues and browns. So that's what we've got there. Now we'll move on to NASA Worldview. This is the Arctic today. I had the sea ice concentration layer turned on. And wherever you see the colors, that means it's melting. And if you see lots of different colors, that's in high melt. And it's opening up. And where you don't see colors, that means there's no ice. Like here. Here in the Laptev Sea, up here in the Laptev Sea, see, that's opened up. There's no ice there. Here, this is in high melt, just to the west of, this is New Siberian Islands. You can see the coastlines. This correlates right along with what we saw in the Navy model. Here's the Bering Strait. See, that's open. See. Here in the Beaufort Sea, see, this is opening up. That was the area I was telling you about. This is opened up here on this Canada coastline. Down here in these tributaries, this is the Nares Strait. Here we can see that that's coming apart here. This is open. Here's Greenland. Here's the Baffin Bay. See, high melt. Here's the Hudson Bay. That's in high melt. And then on this east side of Greenland, that's in very high melt. And we can see, here's the rain. This is that storm. You can see the coming up here. And here to Iceland. Remember, we saw it raining over Iceland. So that's all going away fast. Here's Svalbard, Franz Josef Land. See this, all of this on the right, that's opened up. There's a little fringe of ice left here in the North Barents Sea. Here's the Kara Sea. You see all these colors. It's in high melt. Here's the Yamal Peninsula. Here's the Gulf of Ob. So that gives us an idea, and now we'll go to the satellite view. I like seeing that overlay first, and then we go to the satellite view and we have a reference point for what we're looking at. Let's start down here on this northwest edge of Greenland. So here we go. We can see this is starting to break up, but we're under, it's hard to tell if there's clouds or what. Here we go. This is the Nares Strait. That's breaking up. You can tell there. Let's go back a couple of days and see. Right. See, right along the coastline, that's opening up a little bit. That's a good view. Look, see, that's opened up there on that edge. Let's go back to today. Makes a difference to have the cloud go away, huh? Look at all this open water over here. And then here's the Baffin Bay. See, it's coming apart. And remember, the ice is exiting through here too. Here's the Hudson Bay. See, there's the east side. There's the west side and the north. Here's Canada. See, that's all gone there. Here's Greenland. It's all gone around here, down to the just a little fringe right at the tip, but this will all be melting very fast. See, now these so think of Greenland and what we saw, this salmon color around the edges here. So this ice sheet, it's already melting. See, and we'll be able to see as it melts. See the pieces coming out? It's flowing out already. So all of this is melting. Here's this northeast edge, that's open there. Now let's see what we can see just north. Here's the ice. Let's see, that's packed pretty good. There's a lead there. The leads are these long cracks where it opens up. So here's Svalbard. See, that's opened up around Svalbard. See, that's melting. Here's Franz Josef Land. See, on this right side, that's all opened up. Here's Novaya Zemlya on this bottom side, which is really west. There's no ice there. That's gone, and it's pulling away there on the east side. Here's the Yamal Peninsula. Here's the Gulf of Ob. See, that's melting. This is the Kara Sea. There's a lot of open water underneath those clouds there. Let's see if we can see better. Yeah, here's a better view yesterday. See, the ice kind of goes like that. And see, that's the integrity of it. Some big pieces, some smaller pieces, and then a lot of open water. So here's Severnaya Zemlya. Here is Komsomolets, home of the billowing methane. Here it is today. We've got clouds. Let's go back to yesterday, day before. Here's a good view. 2 days ago. Look at, let's see, that's open. That's all open water there. Look at that. Look at the pattern in the clouds, and I'm not going to say too much about that for YouTube. I do say quite a bit about that on my other channel, but that's one topic I don't talk about here on YouTube anymore. Let's go. But it is affecting lots of things. This is open here. Here we are in the Laptev Sea. Look. See, that's opening up. This is open. Here's the Taimyr Peninsula. See, all the way around. See, this is open water here. Here's New Siberia Islands. And this lead, remember this lead opened up early on. Now, we can see the ice changing colors. That's melting. Let's see, here we are today. See, that's opening up. Here's open water. Here's Wrangell Island. And here's the Bering Strait. I'm going to refresh, see if that'll go away. Okay, we've got all the data now. So here's our Bering Strait. See, that's ice-free. Just a little chunk here and there. And then this comes into the Chukchi Sea. That's melting fast there. Look at, here's Alaska. See, this is all melted here. This is the Beaufort Sea. Here's the coastline. Here we go. See? Uh-oh. Right down here. This is the Amundsen Gulf. Or, yeah, right down here. That's open. Just some big chunks there. But that's... Let's go back. See? Look at all that open water. These are clouds, so that's melting really fast. Here we go. Here's the Canada coastline. Look. Here we go. See? See, that gyre just pulls that ice apart as it goes back and forth. See, we've got lots of holes there. And here's Ellesmere Island. We're back here to where we started. Let's go back to today, see what it looks like. Okay, we've got a cloud kind of moving in over here. Now that other area that was opening up is, I think it's right in here. Let's turn on that sea ice layer. Right here, see the green? So it's right in there. I can't see anything. Let's see if the nighttime layer can help us. Yeah, we got clouds there. Can't really see. There are too many clouds. So that's what we've got. And we'll briefly look at earthquakes. This is the USGS for the last 24 hours. We have 243 worldwide. Now I wanted to show so we got one here on the Juan de Fuca plate 3.2. We've had okay, I wanted to show 7 days all magnitudes. Let's see what's happened. In the last 7 days we've had 2,354. You see this one right up here in the Baffin Bay that happened. That was a 4.2 in the Davis Strait. That was on the 24th. And so we've got Greenland melting. This tectonic plate will be moving up and down. So we'll be seeing, I'm thinking, a lot more earthquakes up here. Look at that. Amazing, huh? So, look, see they're all clustered here. There's the US. Oklahoma had a 4.1 this week. We normally don't see them that big in Oklahoma. we had at Lake Tahoe, we had a swarm a couple of days ago, 33. We had, the largest was a 4.2 that came in on the 28th at 8:25 in the morning. So it's right in the middle of Lake Tahoe. All this started on the 20, well, there was one on the 20, that's Dayton. It all started on the 28th at 5 o'clock in the morning with a 2.9, and then the last one was a 0.9 at 5:28 last night, I mean the 28th at 9:30. So it's all in one day. So things are shaking. Look at these on the Juan de Fuca plate, and here's this Cascadia subduction zone. Here it goes up through Washington, and then we've got the Yellowstone area over here, Idaho, Montana, Wyoming. Look at, here's Alaska and the Aleutian Islands. This whole island chain is volcanic. Let's see, we had an event down here in ADAC. They were clustering there in the 4s and under. And 5.5, that was the largest one off the coast of Japan there. But see, they just follow all of these red lines. Here's China. These are more. Remember that we had the 7.3 here, but these are more that happened this week. And here at Niriganga, now there were a lot more here that were smaller, but these are 4s, 9 here, and the volcano was going off. So, and I saw pictures, it was awful. The lava just overtook Goma. It was awful, and people died and had to evacuate. It's awful. But that's what we've got. That's all I'm going to do on earthquakes today. And the reason I'm doing these shows and this research is because I do believe we are in the end times. And in the Bible, Jesus says, as part of the signs of his second coming, his return, will be the changes, all the earth changes and earthquakes in diverse places, and there are a whole lot of earth changes that will take place. But it's because we are in these end times, and it is we're in uncharted territory on all of this stuff. And so I like to bring it back to a spiritual focus that are you ready to go? If you died tonight, do you know where your soul would go? Now, I finished 1 Corinthians yesterday, and so tonight we'll start on 2 Corinthians. And these are letters that Paul wrote to the Corinthians. The second epistle of Paul, the apostle, to the Corinthians, chapter 1. Paul, an apostle of Jesus Christ, by the will of God, and Timothy our brother, unto the church of God which is at Corinth, with all the saints which are in all Achaia. Grace be to you, and peace from God our Father, and from the Lord Jesus Christ. Blessed be God, even the Father of our Lord Jesus Christ, the Father of mercies, and the God of all comfort, who comforteth us in all our tribulation, that we may be able to comfort them which are in any trouble, by the comfort wherewith we ourselves are comforted of God. For as the sufferings of Christ abound in us, so our consolation also aboundeth by Christ. And whether we be afflicted, it is for your consolation and salvation, which is effectual in the enduring of the same sufferings which we also suffer, or whether we be comforted, it is for your consolation and salvation. And our hope of you is steadfast, knowing that as ye are partakers of the sufferings, so shall ye be also of the consolation. For we would not, brethren, have you ignorant of our trouble which came to us in Asia, that we were pressed out of measure, above strength, insomuch that we despaired even of life. But we had the sentence of death in ourselves, that we should not trust in ourselves, but in God which raiseth the dead, who delivered us from so great a death, and doth deliver, in whom we trust that he will yet deliver us. Ye also helping together by prayer for us, that for the gift bestowed upon us by the means of many persons, thanks be given by many on our behalf. For our rejoicing is this, the testimony of our conscience, that in simplicity and godly sincerity, not with fleshly wisdom, but by the grace of God, we have had our conversation in the world, and more abundantly to youward. For we write none other things unto you than what ye read or acknowledge, and I trust ye shall acknowledge even to the end, as also ye have acknowledged us in part, that we are your rejoicing, even as you also are ours in the day of the Lord Jesus. And in this confidence I was minded to come unto you before, that ye might have a second benefit, and to pass by you into Macedonia, and to come again out of Macedonia unto you, and of you to be brought on my way toward Judea. When I therefore was thus minded, did I use lightness, or the things that I purpose, do I purpose according to the flesh, that with me there should be yea, yea, and nay, nay? But as God is true, our word toward you was not yea and nay. For the Son of God, Jesus Christ, who was preached among you by us, even by me, and Silvanus and Timotheus, was not yea and nay, but in him was yea. For all the promises of God in him are yea, and in him amen, unto the glory of God by us. Now he which establisheth us with you in Christ, and hath anointed us, is God, who hath also sealed us, and given the earnest of the Spirit in our hearts. Moreover, I call God for a record upon my soul, that to spare you I came not as yet unto Corinth. Not for that we have dominion over your faith, but are helpers of your joy, for by faith ye stand. 2 Corinthians chapter 1. So I'm praying for everyone, and if you haven't given your life to Jesus Christ, I recommend you do it now. And as the days get darker, we all need a compass, a spiritual compass, and that spiritual compass is God and Jesus for a lot of people. And He is the one that can protect you from the darkness and lead you out of the darkness and make sure that your soul will be saved when it's time to go. So I love you and I'm praying for you. And until next time, God bless you. Go in peace. I'll talk to you soon. Have a good week. Good night.